Good morning. In this next video, we're going to look at a little bit of algebra. Specifically, we're going to be multiplying some algebraic expressions. So let's take a look at our first example. This example should be viewed as the multiplication of three monomials. So each of these has but one term. In order to evaluate this, we'll begin at the end here where we have this external exponent of 5. So we'll start first multiplying these exponents by 5. And that'll make that last term m to the 10, n to the 5. And now, when we perform the multiplication, we just remember our laws of exponents. So first, -2 times -3 is +6. In working out the exponent of m, we will be adding. Let's not forget the implied exponents here. So for m, we'll have an exponent of 2 plus 1 plus 10, which is 13. For n, the exponent will be 1 plus 5, or 6. Okay, so this was an example, again, where these were all monomials. Let's look at the next one. This next example has a monomial being multiplied by a binomial. So this is now considered two terms separated by the subtraction sign. So we just multiply 5x squared first by 2x to get 10x cubed. The subtraction sign will go next, and then we multiply 5x squared by 8y to obtain 40x squared y. And that's all there is to it. Okay, here we go. Another example with a single term or a monomial out front. This is now a trinomial, 3 terms in total, separated by the subtraction and addition signs. Okay, so we're going to take 6x and multiply it by all 3 terms, adding exponents where we have the same base. So 24x cubed minus 18x squared y plus 36xy squared. Okay, let's look at our next example. Okay, so in example 4 now, what we have here is the multiplication of 2 binomials. So we're multiplying 3x plus 5 by 6x plus 8. So when we do this, we take the 3x and multiply it by the second binomial. Then we'll take the positive 5 and multiply it by the second binomial. And that ends up looking like this: 18x squared plus 24x plus 30x plus 40. Okay, and some of you may start with this step, not including this step. And of course, that's perfectly appropriate. In fact, if you learn that little mnemonic device, you would use the word FOIL, first, outside, inside, last here, to get these 4 terms: first term, outside term, inside term, last term. And to finish it, these are considered like terms. So we would add the 2 like terms together in the middle to get 54x. Okay, so that was the multiplication of 2 binomials. Okay, problem 5 is the square of a binomial. what this means, of course, is that we are multiplying 8t minus 5 by 8t minus 5. So how is this accomplished? In the same way that we did problem 4. So first we take 8t and multiply it by the second binomial. Then we take the negative 5 and multiply it by the second binomial. This gives us 64t squared minus 40t minus 40t plus 25. And these would be first, outside, inside, last. First, outside, inside, last. Collect those middle terms together. To get the final trinomial. Okay, let's look at example 6. All right, so example 6 starts with a binomial multiplied by a trinomial. So we take the first term of the binomial and we will multiply it by the trinomial. Then we take the second term of the binomial, which is negative 4b, and we will also multiply it by the trinomial like this. Okay, so in this way, we are going to get six terms, which we would expect because we are multiplying 2 by 3. 2 times 3, so we should have 6 terms in this next line. So 15a cubed plus 18a squared b minus 6ab squared. Those would be the first 3 terms. And now we'll generate the next 3. So negative 20a squared b minus 24 ab squared plus 8b cubed. And notice that within each term, we're using a natural order, which means, you're going to have the numeric part first, and then we follow alphabetical order. So you're seeing here, I'm writing the terms containing within each term, we're writing A before B. Okay, similarly with all of the terms. So the number and then alphabetical order for the literal terms. Okay, so we ended up with this, and now of course we're looking for like terms. So we can see here, I think, a squared b on these 2 terms. So we collect them. So we have 18 of them and negative 20 of them. So that will give us negative 2 of them. And here, look, ab squared. So there are 2 terms containing ab squared, which can be collected together. So negative 6 of them and negative 24 of them. So that will give us negative 30 of those terms. So in the end, we end up with this: 15a cubed minus 2a squared b minus 30ab squared plus 8b cubed, like that. Okay, 2 trinomials. So the process here will be the same, except when we multiply 3 by 3, we're expecting 9 terms in the expansion. And the difficult part will be to get this to fit across my lined paper, but we're going to take 3x squared, multiply it by the trinomial, and then add 2x after multiplying it by the trinomial, and then subtract 1 after multiplying it by the trinomial. So like this, I'm gonna write a little bit small. So 3x squared gets multiplied by the trinomial. Positive 2x is multiplied by the trinomial. And finally, negative 1 is multiplied by the trinomial. And in that way, I will have my 9 terms. So now I'm just going to do the multiplication here. 15x to the 4 minus 9x cubed plus 21x squared. And now the multiplication here. Plus 10x cubed minus 6x squared plus 14x. And now the multiplication here. Negative 5x squared plus 3x minus 7, like this. Okay, and now we collect like terms. So there are 2 terms containing x cubed. So we'll be collecting these together, negative 9 of them, positive 10 of them. So we will have 1x cubed. There are 3 x squared terms. 21x squared minus 6x squared minus 5x squared. So that will give us positive 10x squared. And terms containing x are here and here, 14 and 3, so 17x. Okay, so that means we will have this. 15x to the power of 4 plus 1x cubed plus 10x squared plus 17x minus 7. Okay, so this is written in descending order of degree, which is very common. Okay, I think what we'll do is one more example together. So in this last example, we will cube a binomial. Cube a binomial. So we have to realize that this means 2 minus 3y multiplied by 2 minus 3y multiplied by 2 minus 3y. And we begin by multiplying any 2 of the binomials together. So I think that I will begin by multiplying these latter 2 binomials together. Okay, so when we go to multiply them together, remember what we're going to do is we're going to take the 2 here and multiply it by that second binomial. Then we're going to take the negative 3y and multiply it by that second binomial. And in this way, we get the 4 terms corresponding to first, outside, inside, last. Okay, so again, many of you skip this step, which is completely fine. Okay, and you would go right to this step, which is first, outside, inside, last, like that. And before continuing, of course, we'll collect these middle terms here to get 4 minus 12y plus 9y squared. Okay, so the square of 2 minus 3y is 4 minus 12y plus 9y squared. And some of you probably would go right from here to here as well. And that's, again, perfectly appropriate. So we left the first binomial out front. We multiplied the last two binomials together to get this trinomial. Now we have to continue. We have to take the binomial and multiply it by the trinomial. So we know how this goes. The 2 is taken first and it is multiplied by the trinomial. Then the negative 3y is also multiplied by the trinomial. And this is how we get our 6 terms. 2 times 3, 6 terms. And they are 8 minus 24y plus 18y squared. And then negative 12y, positive 36y squared, negative 27y cubed. And now we collect like terms. There are 2 terms containing y, and there are 2 terms containing y squared. So these terms are now added. So after the 8, I will include negative 36y, and then 18 plus 36, or positive 54y squared, and then finally negative 27y cubed. And this time the terms are written in ascending order rather than descending order, and that's because the original binomial had an ascending order of degree as well. So the exponents go from y to the 0, y to the 1, y squared, y cubed, which is perfectly appropriate. Okay, so thanks for watching. As always, please look for the recommended practice problems. You'll find these in the Blackboard posting directly beneath the video link. Have a great day.